So in this part of this unit, we're going to try and deal with the various logic errors that might be going on in our code. So logic errors are hard to work out, and so therefore it's worth trying to avoid introducing logic errors in the first place. This is a bit of the standard sort of how do you give directions. Well, I wouldn't start from here. But there are strategies we can adopt to try and minimise the chances of introducing logic errors into this. So the first thing I'd always go and do is say add docstrings to your functions. So a docstring, to remind you from first year, it's the way you can get Python to built-in self-document the code as you write it. And the purpose of a docstring is to explain to future you and anybody else who is using your code what your code is designed to go and do and how you should use it. So docstrings are always a standalone string, so they're not assigned to anything, they're just a string that sits there, and it's always the first line of a function, or indeed of a module. So the docstring is something that Python will automatically recognize, and it can go and use it, but only if you put it in the right place. So it is the thing that comes immediately after the def line in a Python function definition. And a good docstring that you write, so it should have probably at most a one-line summary of what the file is going to go and do, and then it should go and tell you about how that function is used. Let's go this way. So, contents of a docstring. You have a brief summary of the purpose of the function, a list of the parameters that the function takes, and what data types those parameters are expected to have, and what they mean. It should also say what does the function return, i.e. what data type it is, and what's the meaning of the return value. And then it should have other notes of explanation about how the function works, or things a programmer might need to know about it, like under what circumstances will it not work. It might say about what exceptions the function is likely to raise, what they mean, and what the significance of that would be. So often docstrings can also contain examples of the use of a function or cross-references to other functions. They get really quite complex, and actually many times you're going to find the docstring can be as long, if not longer, than the actual body of the function, and that's absolutely fine. Depends a bit on what the purpose of the function is and how you're expecting to be used. But the thing that I want to really emphasize to you is that don't write docstrings as the thing you do after you've written the function. You should write docstrings before you start writing the code of the function, because the docstring is how you tell yourself and remind yourself exactly what it is that this function you're about to write is supposed to go and do. Because if you have that clear in your mind before you start writing the function, then you'll find it a lot easier to make sure you write the correct function and don't write something that has random extra problems in it. So let's go back to our code. And we're now going to look at the version where I've written in the docstrings. So the first thing you notice is I'll actually put a docstring at the start of the file. That will become useful in due course. So that goes right at the start, even before we do the imports, and it's a brief summary of what the purpose of the file is, or the code in this file. So here's the function we had before, the find routes. So I have a one-line summary of what it's going to do. I give it a list of arguments. There's different conventions for how you can format the docstring. I don't really care that much which convention you use. The one I'm using is a variant of what's called the Google style of writing docstrings, but there are other ones out there. As long as you're consistent, that's the main thing. But you see I have my arguments, I have what data type it is, and I have what does it mean? And then I have what it returns, and it tells me the data type it returns and what it means. And then I have a notes section, and I've just noted that this doesn't handle complex routes. So it assumes that my kernel is going to be real. And then the same on the getCoefficients function. Again, I have a one-line summary. It doesn't take any arguments, so there's no argument section, but it does return things, and it notes. Again, this is a kind of, they're forced to be integers. I might wonder why it's doing that. And the purpose of doing this is because if I run this code, let's just stop it from actually executing those lines at the bottom. Oh, I've still got my input function there. I said I'd change that. There we go. So I'm going to run that code, and because I've got those doc strings defined, find routes, hit Control I, and you see in my help window in Spider it's now displaying what I have from my doc string, and it's not terribly formatted. Could be a bit better. Let's see if I can tidy that up. Sometimes the formatting that Spider applies goes a little bit awry, but it's not far off. If I do that again, oops. That's more like it. So you see it's given a nice list of the arguments, the data type, what they mean, the return value, and the note. So it's then very clear. Now the point is, if I write that first before I write the code, then I've always got that sitting there telling me what it is that this should do, what it should return. It makes it much less likely I'm going to make a mistake writing that function. So this comes back to another bit about a good coding strategy, and that is, don't just start writing code straight away. Actually, it's worthwhile spending a bit of time with pen and paper, just trying to split up your problem and think about, well, what function am I going to need? What would it take? What will it return? If you spend the 5 or 10 minutes doing that before you start writing code, you're less likely to go and make mistakes later on in the code.